Okay, example number 4 in section 3.2. So even though the right side looks more complicated, we just learned the identity for the left side, so let's go ahead and plug that in. So I'm starting with the left side, tangent to theta. So looking at my notes to remember what that identity is, because I sadly don't have it memorized. It is 2 tangent theta divided by 1 minus tangent squared. So I've just taken tangent to theta and replaced it with this double angle identity for tangent, right? So double angle identity. If you want to, explain as you go along what you're doing, it's helpful to you if you have to go back and look at it later, or helpful to whoever might be grading a test or something that you've done. Okay, next, notice the answer we're trying to get to has cotangents and tangents in it. So I'm not sure that we want to change anything to sines and cosines. So we might want to think of a different way to approach this problem. We do want to get rid of the tangent in the numerator. Is there a way to get rid of something, like turn it into 1? Is there a way to just turn this into 2? How could we possibly get rid of this tangent? We can multiply something, we could divide something. That's usually your best bet. You don't want to usually just add or subtract stuff. It's more like you want to work with your fraction in getting an equivalent fraction, right? So when they do weird stuff like this, it's like, how would I even have thought to do that? I guess you just have to practice. But what if we took our 2 tangent theta and we multiply it by 1 over tangent theta? So I'm going to go ahead and write that as though I've done that. And then I'll explain kind of what I did. So let's start with that. 1 minus tangent theta. And then, oh, that should be squared. And then divide that also by tangent theta. So what I've kind of done here is I've multiplied both the numerator and the denominator by 1 over tangent theta. And by doing that, I've multiplied by 1, right? Because I've multiplied the same thing on the top and the bottom. And so then those two things reduce. And we've talked about this before. When you have fractions in a fraction and they have the same denominator, it cancels out. So it should make sense that we could put it in and it still has the same value. Okay, so what does that accomplish? That means we can reduce this. That was our main goal. So that puts the 2 in the numerator right where we want it to be, like it is in our right-hand side. Now for the denominator, it maybe isn't quite so easy. Let's rewrite our fraction. So I'm going to rewrite the denominator so you can see this next step a little better. So we would have 1 minus tangent squared theta over tangent theta would be the same as 1 over tangent theta minus tangent squared theta. Ugh. I'm really having a hard time writing what I'm saying. I don't know why. There's a disconnect between my thinking, my speaking, and my writing. The struggle is real today. Okay, so we have tangent over tangent. So you can see how I've split up my fraction into 2 fractions. Usually we're adding fractions together. This time we're splitting them up. So now, hopefully you're beginning to see what's happening here. 1 over tangent, that's the reciprocal of tangent, that's cotangent. and then subtract. So this one here, we end up with 2 tangents in the numerator and 1 tangent in the denominator, so those reduce. So we just have 1 tangent in the numerator left over, and that is our right-hand side. We're done.